afternoon. Today we are making the video for our math packet number 10. It is due on the 15th, which is next week, Tuesday. So if you want to be able to make corrections, get it to me by Friday, and you can make your corrections. Final packet is due on Tuesday. Our first page, Alexis and Vini drove to Philadelphia for the weekend. They decided to see some of the landmarks and needed a place to park for 3.5 hours. They see two signs advertising two different parking lots and go with the cheaper cost. How much do they pay? So you need to figure out if they're parking for 3.5 hours. If they go to Pat's parking, figure out how much they're going to pay. Then figure out how much they're going to pay for Paul's parking using our different rates. Decide which one is the cheapest and write that amount on the line. Eleanor?
I was wondering if are they two different cars or are they both in the same car?
They're in the same car. So they have one car.
Okay.
They're going to be parking at either Pat's parking or at Paul's parking.
Okay.
Okay? Most of us have been able to figure this one out on our own. It's this one that has been giving us a lot of trouble. So the train leaves the station at 1 p.m. So at 1 p.m. they've gone a distance of 0. It travels at an average rate of 60 miles per hour. So at 2 p.m. it's gone 60 miles. A high-speed train leaves the same station an hour later. So at 2 p.m., the high-speed train has gone 0 miles. That's when it leaves. So at 3 p.m., this train that was going 60 miles an hour has now gone 120. This train has gone 96, because it's going 96 miles per hour. The second train follows the same route as the first train on a track parallel to the first. In how many hours and minutes will the second train catch up to the first train? So in that first hour, it hasn't caught up yet, but it's getting close. So you're going to go to the 4 p.m. You're going to add that 60 on for the first train, and it's going to be 180. Add 96 and 96, and it is whatever it is. It is 192. It has passed it and gone farther, right? So we need to figure out at which point in between 3 p.m. and 4 p.m. does it actually pass it. So you're going to break it down to the minutes. How far is it going? I broke it down into increments of 5. First I did the half hour, then I did 15 minutes, and then I ended up having to go down to every 5 minutes. Okay? Break it down. How far are they going in those small increments of time? Was yours the one? It's close. So you were on the closer track than I was, but that's not correct. But it's close. All right, so you're going to want to say how many hours and how many minutes. So break it down into the minutes. How far are they going each minute? For our 5-card challenge, I had some friends say, hey, we've got an ace in there. If I have, let's say 10 divided by 2 equals 5. Can I throw a 1 in there times 1? And that's a whole new equation? It sure is. That's how people get really super high counts for how many equations they can find, because they're using that math sense. I could do to the first power. I can multiply by 1. I can divide by 1. You're using different operations. They all count as different equations. But you can only use that one time in each equation. See how many equations, how many points you can get. This is how people get oodles of points. Challenge yourself. See how many you can get. This one, you need to complete the table up to that 9th figure. Don't forget that when you're counting how many yellow on the outside, count how many yellow on the inside. You're going to find patterns. So let's fill in what we know so far for our first 5 figures and then look for our patterns. We had 1 yellow, 0 pink, 0 blue, 0 red, so 1 total. 1 yellow, 8 pink, 0 blue, 0 red for 9 total. 1 yellow, 8 pink, 16 blue, 0 red for 25 total. 1 yellow, 8 pink, 16 blue, 24 red for 49 total. For our 5th figure, that yellow jumps from a 1 up to 33 because you count the outside and the inside. Our pink is 8, our blue is 16, our red is 24, and our total is 81. Now look for patterns. First one, what's my favorite kind of number? Perfect squares. Right? Do we see perfect squares on here? Where do you see them? The totals. 1 is 1 squared. 9 is 3 squared. 25 is 5 squared. 49 is 7 squared. 81 is 9 squared. Can you follow that pattern down? You can fill in those totals. Other patterns. How many times in a row do we have the same number before it jumps up to a bigger number? Addie? 4 times. So I have 4 1s. I'm going to need 4 33s. I've got 4 8s. Oof, I'm not sure what comes next. I need 4 16s. I need 4 24s. All right. Now, I know what comes next in the totals pattern because I'm jumping up by those odd numbers and I'm squaring them. I can take what I know, my total, subtract out to those ones, and I'll be left with that pink. Then I'll be able to fill in all those pinks because there's 4 in a row of the same number. I can fill in this number. I can subtract what I know away and be left with that blue that I didn't know. So follow those patterns. Okay? Then you're just left with those 1 spots that we don't know. For this one, area of the figure, that is that full figure. Remember, the area of a rectangle is length times width. So you want that full figure of the length times the width. Now the area of the shaded region is a goofiness, but we know the white is a triangle. To find the area of a triangle, you do 1/2 the base times the height. The base is the bottom of our triangle. The height is going from that base straight up to that tip of the triangle. So you extend your base out and you go straight up to the tip. So that from here to here is my height. Once you know your white triangle, you can subtract it away from your full to be left with your shaded. On our next page, you need to draw a net and label the sides. Be careful. I've already caught some people saying that this is a 12, so they think all the sides of the triangle are a 12, and they match up with the sides of the rectangles. When we draw our net, that bottom is bigger than those sides. So we need to pay attention to that with our triangles. That's our on the ends. So if this is a 10, this is a 10, and this is a 12, this 10 doesn't match up with the 12. it matches up with a 10, because when we fold it up, they need to match up. So make sure, oh, you need to find your X, so we know what our length is. We know that the volume is 960. We know the volume is length times width times height. We know our one number here, we know our height. We're looking for that width. So the length is 12, the height is 8. We're looking for our width of X. We know our volume number. Do opposite operations to find your X. Then you have to find the area of each of these shapes, add them together to get your surface area. Okay, we've done those kind of things with our nets before. On this page, let's fill in our formulas. Rectangular prism is length times width times height. The cube is that side cubed. So it's that length times the width times the height, but they all have to be the same number to equal that. That triangular prism is 1/2, length times width times height. The pyramid is length times width times height divided by 3. Our cylinder is pi r squared times the height. The cone is pi r squared height divided by 3. And our sphere is 4/3 times pi times r cubed. We've done these pages in the last few packets. So knowing our formulas and knowing those volumes, you should be able to fill them in. This is another new kind of page. The way this page works, there's lots of explanation. I'm going to break it down real easy. N equals 5. So we add a 1 to that and we go to F6. There are going to be 8 combinations that we need to make, where N equals 5 using only 1s and 2s. So like 1 plus 1 plus 1 plus 1 plus 1 equals 5. That's one of our 8 combinations. You could do 2 plus 1 plus 1 plus 1. That equals 5. Then shift that 2 to different places in our equations as long as it equals 5. There are 8 possible combinations that you need to write using 1s and 2s. Down here, composition of 1s and 2s, where n is 6. So we add 1 to that 6 and we get that F7. So that means there are 13 combinations using 1s and 2s, adding them together to equal 6. So you need to find all 13 combinations using 1s and 2s that will equal 6. Make sure you don't repeat any combinations. Make sure that they equal 6. Our next page is an extra credit page. There is no pre-algebra page. Some of us have been attempting it. Give it a try. You could get an extra credit point. And our last page is that polyominoes. All right. So if you have questions on your packets, make sure you come ask me. Remember, turn it in by Friday and you will be able to make corrections on it. It is due next Tuesday. I hope you are well and I will see you soon. Have a wonderful day.